Okay, so this next lesson is about counting principles. The biggest thing is about permutations versus combinations. Permutations means that the order matters and combinations mean the order does not matter. Here are the two different formulas for them. They're pretty similar. Your calculator can do this. Just go to the math button and then the probability tab, but you should know how to calculate these by hand as well. So we're just going to jump right into it. In how many ways can the letters of the word candle be rearranged? Well, in this case, we're just going to use the plain factorial. There are 6 different letters. So if I have 6 different letters, then 6 factorial is the same thing as 720 different ways. The second one asks, in how many ways can a group of 4 boys and 3 girls be arranged? So in this case, we're just left with 7 factorial because there's 7 children. The gender doesn't matter. It's just putting them in any order whatsoever. So we have 5040. Your calculator can also do factorials for you, but just keep in mind, sometimes you might have to do them by hand. So then the last one, in how many ways can a group of 4 boys and 3 girls be arranged if no girls are to be next to each other? Well, the first thing that I want to look at is I know that the different ways that the 4 boys could be grouped together. So there are 4 factorial combinations of that. Or arranging that. And then there's 3 factorial ways of arranging the girls. So just in terms of the order that they could be organized. And then in order to make it so that no girls are next to each other, there are 4 boys. I think it helps to draw a picture. And then the girls, there are 3 of them. They can fill any of the following slots. So we have 1 slot, 2 slot, 3 slot, 4 slot, 5 different slots that they could fill. So that means that there are, we're going to use the combination. So in CR, meaning the order doesn't really matter. So we have the number of options, the places that they could be is 5 combination, and then the number of R objects, how many girls are there? There are 3. So once this right here, 5CR is the same thing as 10. So we have 4 factorial times 3 factorial times 10, which is 1440, I believe. Okay. All right, so moving on from there. I have that there are 8 boys and 5 girls who attend a senior mathematics club. And then the teacher can choose 6 students to represent a school competition. So the first way is to figure out if there are no gender restrictions, meaning I just need some combination of girls and boys to make 6 in a team. So there are 13 different kids to choose from, and the team is only 6 people. So you can use the formula or plug it into your calculator. You should end up getting 1716. For part B, if it's to be made up of 3 boys and 3 girls, we multiply the combinations. So the number of combinations that there are for boys times the number of combinations that there are for girls. And so that would be 560. Okay, and then the last one has 2 different ways to do it. It says at least 2 of each gender are included in the team. So I think the most straightforward way of thinking about this is to figure out what the combinations are. And this way works because the numbers are so small. But if you have bigger numbers, you need to use the other method. So in this case, if we have 6 people on the team and there has to be at least 2 boys, then we could have 2 boys, meaning there would be 4 girls. We could have 3 boys and 3 girls, or we could have 4 boys and 2 girls. Okay? So from there, what I need to figure out is each of those. Luckily, this middle one we just answered in part B. That would be 8C3, 5C3. This one here would be 8C2 times 5C4. This one here is 8C4, 5C2, and I think this one comes out to be, and then you just add all of these together, and I think that comes out to be 1440. I could be wrong on that one, but the other way to look at this one is to figure out if there are two of each gender on the team. That means I can take the total number of permutations or combinations from answer 1, and then subtract the cases where there are 0 boys / 0 girls, which, hang on, 0 girls, which there is no case where there could be 0 boys, because then you wouldn't have a full team. The time where there is 1 girl and the time where there is 1 boy. So I could also do my answer from part A, which is 1716 minus 1716 minus 8C5, 5C1. So that's the time where there's 1 girl, the time where there are no girls, and the time where there is 1 boy. Oh, that should be 5C5. So then what you end up getting should be the same answer of 1440. Okay, so that is it. The Delta Math, again, I only assigned 1 question per thing, but I think that it should be pretty straightforward. Just lots of practice will help.